So we're going to talk about cross sections today. And before we do that, I just realized I messed up a slide, so give me 1 second. Okay. So today we're going to be talking about cross sections and the cross sections of three-dimensional figures. Today your assignment is to take notes. If you have to pause the video to draw the pictures, if you have to download the pictures, anything, I want you to take notes on this slideshow, and I want you to focus on what cross sections are. So the one thing I want you guys to know is we are going to have more videos on this throughout the week to give you some practice and some actual manipulative examples. Right now I just want you to follow along, get the definitions. So first thing we're talking about is cross sections are the 2D shape created when cutting through an object. So we have this object right here. We have this triangular prism that they cut directly in half. The new shape, the new face that was created when they were cut is a triangle. So that is what the cross section is. The cross section is that triangle. So in geometry, it is when a three-dimensional solid figure is cut by a plane, the new side, again, is going to be your cross section. So we have the square pyramid right here. If we were to cut it directly across and take this top part off, just take it right off, the new face underneath that is going to be the square. Right here again, they cut it directly across. We know it's a square prism. If they cut it directly across, if we were to take this top part off, this new top section, since it's parallel to this one, is going to be the same. Right here, if we cut it directly across, it'd be the pentagon. Here they cut it vertically, so this one's a little different. Since they cut it vertically, if I were to cut a pyramid in half vertically and separate the two pieces, separate it into two pieces, the new side is going to be a triangle. And here you cut it directly in half. It's parallel to this side, it's going to be a rectangle. If we cut this one right here, it'd be a circle. So example right here, we have the cylinder. If you were to cut it horizontally, like we did in the last one, the new shape is a circle. If you were to cut it vertically and separate it, the new shape, this shows a parallelogram, but in reality it's going to be a rectangle. This is a rectangle that they're going to cut. If you were to cut a cylinder directly in half, the new face would be a rectangle. So next is the torus, which is kind of a curved figure with all rounded edges, kind of like a noodle ring. So if you were to cut it vertically, like they show right here, you only have two sections of the cross section, right here and here, which are two circles. Now, the cross section depends on how the plane cuts the solid figure. So right here, let's look at the bottom and then we'll go to the top because the top's a little different. If you look down here, we have pretty much a rectangular, or a square prism actually. So we have a square prism right here. If we were to cut it vertically, like before, the vertical side shows a rectangle. If we were to cut it horizontally, it shows a square. If we were to cut it diagonally, it makes a completely different shape. Or a parallelogram. Cones are a little different. Conics are a little different. We're going to focus on how the shapes change, especially with cones and cylinders. So for this one, if we were to cut the cone parallel to the base, it would make the same figure as the base, or a circle. You can also make an ellipse if you cut directly diagonally through the figure. If you were to cut this figure diagonally, but not go through the base. So if you were to just cut off a bit of the side, we know this part right here is an ellipse, or an oval, but in geometry it is known as ellipse. If you were to cut it diagonally again, but it goes straight through the base, you'd have a parabola, or a figure with one straight base and a curved line. And the hyperbola, which is just a funky looking parabola. So we're going to go through a few examples. I want you guys to take notes. If you want to go through some of these, you can go to Khan Academy and type in cross sections. It'll give you stuff to work on. So it says, which of these objects below can slice to create an ellipse, non-circle of the cross section? Well, we know the cone just showed us over here. that you can have an ellipse. So that's one of them. Next, can a sphere, if you were to cut the sphere in any way that wasn't directly across, it could. Cylinders, do these have curves? Right here, these three? No. Oh, let me get rid of the sphere. So, spheres cannot, because no matter how you cut a sphere, it is still going to make a circle. Okay? Next, it says, what two-dimensional cross-section can be created by slicing a sphere? Well, we know it's not an ellipse. We know it's not a hexagon because there's no edges. It's not a quadrilateral. Again, there's no edges. Same with triangle. So let's try circle. Circle is the only thing that can be made out of a sphere. Which objects can be sliced to create an equilateral triangle at the cross-section? Okay, let's look. This can make an equilateral triangle because it has an equilateral base. So cones are a little different. They cannot be, well, yeah, they can be equilateral depending on the size. But most of the time they make isosceles triangles. So it says is incorrect. So I think it depends on the shape of the cone. Most cases they make isosceles triangles, not equilateral. Okay? So the last one, the two-dimensional cross-section slicing the right rectangular pyramid. So we know it can make a rectangle because it says rectangular pyramid. It can make a trapezoid. Rectangle. That doesn't make any sense. Oh, it's right rectangular, so that means the base is, I should have. Make sure you guys read directions. Make sure you read them. Alright, well that is what